Hello students, welcome to Aimsindia online classes. In this chemistry session, we are going to discuss about the practice sheet related to the chapter acids, bases and salts. So before going to see the practice sheet, here let us give a glance on the concepts which we have learned. See here about acids, bases and salts. We have seen different concepts like what are called acids, what are the properties of those acids. Those all we have seen. We observe once about the acids. What is the taste of those acids, nature and examples we have seen. About bases also, how do they touch, what are the taste of those bases and examples. And if you see indicators also, we have seen different kinds of indicators like natural indicators, synthetic indicators and examples for each kind we have discussed. And about neutralization also, neutralization means the reaction of acids and bases to form salt and water, that also we have seen already. Next, the applications of these neutralization reactions in our daily life. About this also we have seen. So based upon these all concepts, we are going to have a practice now. Okay, let us start the practice sheet. The first question: moist sodium bicarbonate was placed on a strip of pH paper. Then the color of the strip. What happens to the color of the pH paper when sodium bicarbonate was placed on it? What is the nature of the sodium bicarbonate? If we know that, we can answer it. We know sodium bicarbonate acts as a base. So what is the reaction or the color change of pH paper with the bases? It turns blue. So when moist sodium bicarbonate was placed on a strip of pH paper, its color turns to blue color. We know the pH range, pH color range is from dark red to dark blue. If it is a basic substance, the pH color will be blue color. If it is a acidic substance, its color will be red color. If it is a neutral substance, its pH color will be green color. So in this way, the pH paper shows different colors with the acids and bases. If it is a base, its color will be changed to blue. So as here, moist sodium bicarbonate is a basic substance. The color of pH paper turns to blue. Okay, next one. 10 ml of a solution of sodium hydroxide is found to be completely neutralized by 8 ml of a given solution of hydrochloric acid. If we take 20 ml of the same solution of sodium hydroxide, then the amount of hydrochloric acid solution required to neutralize it will be, yes, here if you observe initial the conditions, 10 ml of sodium hydroxide completely neutralized by 8 ml of hydrochloric acid. So from the same solutions, again they have taken 20 ml of sodium hydroxide. Simple logic, need not to calculate also. 10 ml is neutralized by 8 ml. Then 20 ml will be neutralized by 16 ml, double the amount. So 10 ml of sodium hydroxide base is neutralized by 8 ml of acid. If we take the double the amount of base, then the acid also required will be double the amount. 16 ml of hydrochloric acid neutralizes 20 ml of sodium hydroxide solution. Okay, it is 16 ml. Need not to calculate, directly you can say. Next, let us see here. Answer is given already, no problem. When the stopper of a bottle containing colorless liquid was removed, the bottle gave a smell like that of vinegar. The liquid in the bottle could be, yes, we know the vinegar. Vinegar is containing an acid called acetic acid. So the smell of vinegar is because of the presence of acetic acid in it. So the liquid contains acetic acid, which we commonly call as vinegar. Okay, next question. A solution reacts with crushed eggshells to give a gas that turns lime water milky. Then the solution contains. Yes, what they have done here? They have taken crushed eggshells and they made to react these with a solution. Then a colorless gas is produced. Okay, gas is evolved and the gas turned this lime water milky. We know the gas which turns lime water milky. Which gas turns lime water milky? It is carbon dioxide. We know as that it is test for carbon dioxide also. How do we test carbon dioxide? When you pass carbon dioxide gas onto lime water, that lime water turns milky. So from this statement, we can understand the gas produced is carbon dioxide. And we know one more thing also here, eggshell. Eggshell is mostly made up of calcium carbonate. Calcium carbonate is the main component in the eggshell. So eggshell producing carbon dioxide gas on reaction with a solution. When this calcium carbonate will generally produces carbon dioxide on reaction with acids. So the taken solution should be an acid so that this is acid reacts with the eggshell or calcium carbonate and hence it produces carbon dioxide gas. Okay, so the solution taken is an acidic solution. Observe the options given, which is an acid. We know sodium chloride, lithium chloride, potassium chloride. These are salts, whereas HCl is an acid. So when this eggshell reacts with hydrochloric acid, then it can produce a gas which turns lime water milky. Okay, HCl. Next one. Chemical formula of baking soda. What is it in baking soda? Baking soda is nothing but sodium hydrogen carbonate, or to say simply sodium bicarbonate. Its formula is NaHCO3. Baking soda is chemically sodium hydrogen carbonate or sodium bicarbonate. Its formula is NaHCO3. Okay, next question. If pH of a solution is 13, it means it is. What does it mean pH 13? We know the pH ranges from 0 to 14. The pH range is 0 to 14. If the pH is in between 0 to 7, then that represents acid. If the pH is in between 7 to 14, that represents a base. If the pH is exactly 7, then that is said to be neutral solution. So here we are telling the pH range between 7 to 14 is basic range. As the pH value increases, reaching 14, basic nature also increases. So if it is nearby 14, that is said to be strong base. So in the question it is given, if the pH of a solution is 13, means it is almost near to 14. So as the pH value increasing from 7 to 14, basic nature of the solution will be increased. So as it is being pH value 3, that will be a strong base. So it is strongly basic. Okay, next one. Read the following paragraph and answer it. On heating gypsum at 373 Kelvin, it gives plaster of Paris, which is used for supporting fractured bones and for making toys, materials for decoration, etc. Now, the ratio of water molecules in gypsum and plaster of Paris. So here they are asking about two compounds. One is a gypsum. So generally, when this gypsum is heated, it gives plaster of Paris. Both are useful. This plaster of Paris is specially used in supporting these fractured bones and making some toys and materials, decoration items in this all. Now the question is the ratio of the water molecules present in gypsum and plaster of Paris respectively. So if we know the formula, then you can identify the ratio. So these two are called hydrated salts actually. Hydrated salts means the salts which are containing water molecules in their formulae, in their crystal structure. They are called hydrated salts. And the number of water molecules present in each molecule is known as its water of hydration. Now, if you see gypsum, it has the formula CaSO4, CaSO4, 2H2O, means each molecule of gypsum contains two water molecules. So there is a formula of gypsum. At the same way, the formula of plaster of Paris is CaSO4 half H2O. Calcium sulfate hemihydrate it is called. CS4 half H2O. It is plaster of Paris. Whereas gypsum is CS4 calcium sulfate di-H2O, dihydrated, means 2H2O. Now if you observe the number of water molecules in both, calcium sulfate 2H2O, gypsum contains two water molecules, and the number of water molecules in plaster of Paris are CaS4 half H2O is half molecule. In each molecule there is one half water molecule. Nothing but two calcium sulfate molecules will be held by one water molecule. So to say in simple molecule, half water molecule will be represented in the formula. Now this is the ratio we get the number of water molecules in gypsum and plaster of Paris respectively. Now if you take the ratio of these two, 2 is to half, what do we get? We cross multiply, so 2 will come and it will be multiplied here. It becomes 4 is to 1. Where is it? The first option. Okay, it is the ratio. Let us see next one. Three students were given colorless liquids X, Y, and Z of water, lemon juice, and a mixture of water and lemon juice, respectively. Means here X is purely water, Y is lemon juice and a mixture of water. So mixture of lemon juice and water is given as Y, and Z is purely lemon juice. Now the question is, after testing these liquids with pH paper, the following sequences in color change of pH paper were reported. What will be the color changes with pH paper? That is a simple question here. Let us observe once. First one is water. We know water and neutral solutions will give green color with pH paper. Green. So the solution X gives green color. What about Y here? It is lemon juice and mixture of water. Mixture of lemon juice and water. So as there is lemon juice in water, it resembles acidic solution because lemon juice contains some acids like citric acid and ascorbic acid. So by the presence of these acids, second solution, that is Y, will give the color change red. Okay, red. It changes to red color. What about the third solution Z? It contains purely lemon juice. So this Z also an acidic solution. So Z also shows the color change red. Now X is giving color change green, whereas Y and Z are giving color red with pH paper. Now what will be correct answer? The third one. That means C. Okay, X is giving green color, Y and Z are representing giving red color with pH paper because these two contain acid. Next, the gas evolved when an acid reacts with metal carbonate. Yes, what happens when a metal carbonate reacts with acid? We know when acids react with metal carbonates, they produce salt, water, and carbon dioxide. For example, let us see one equation reaction of sodium carbonate. We know its formula Na2CO3. Sodium carbonate Na2CO3 on reaction with dilute hydrochloric acid. So metal carbonate on reaction with an acid, hydrochloric acid. they give a salt. Here the salt will be NaCl and water. Along with these two, salt and water, here the gas produced will be carbon dioxide. So when a metal carbonate reacts with an acid, it produces carbon dioxide gas. The carbon dioxide gas will be produced. So the answer is A. Next one. Setting of plaster of Paris takes place due to. Yes, when we take this plaster of Paris and it is molded into different shapes, and after drying, it becomes hard on wetting. After few hours, it becomes hard. That is called setting. So this is because of the hydration of this plaster of Paris and converts into gypsum. We know the number of water molecules in plaster of Paris is half, and when it is hydrated, it takes number of water molecules and converts into gypsum, and it becomes harder. So here the setting of plaster of Paris is because of the hydration. Next, a solution turns red litmus blue. The pH is likely to be. We know the solutions which turn red litmus blue are basic solutions, and the pH range of these basic solutions is what is it? 7 to 14. So 0 to 7 means it is acidic. Now, if it is a basic solution, the pH range is in between 7 to 14. See the number which is given in between these two numbers, 7 and 14, which is at, yes, 10. So the solution with pH value 10 can change red litmus blue. Next one. Which of the following gives carbon dioxide on heating? This we have seen in different questions earlier. Let us say once again. Which gives carbon dioxide on heating? Generally, the compounds which are called carbonates and bicarbonates. Generally, carbonates and bicarbonates on heating, they give carbon dioxide. So, among the given, limestone is one of the carbonates. So this on heating gives carbon dioxide gas. So limestone on heating, it gives carbon dioxide. Limestone represents calcium carbonate. So this calcium carbonate on heating converts into or splits into calcium oxide and carbon dioxide. So in this way, generally carbonates and bicarbonates, they give carbon dioxide gas on heating. So here limestone is one of the carbonates, so it gives carbon dioxide on heating. Next, which of the following is not a property of acid? We know certain properties of acids. Let us see here what they have given. All acids have sour taste. Yes, generally acids are sour in taste. Next, acids turn blue litmus red. Yes, acids will turn blue litmus paper red. These are properties of acids. See third one, acids are bitter in taste. Is it correct? No. Which will be bitter in general? Bases are bitter in taste, not acids. The taste of acids is sour in common. Next, most of the acids give H plus ions in water. Yes, acids on aeration, they produce H plus ion in water. This is also correct statement. Most of the acids, they contain hydrogen and they liberate H plus ions on dissolving into water. So this is also correct statement. Only the wrong one is the taste of acids is being bitter. It's wrong. Taste of acids is sour. Next, match the both the columns and mark the correct option from the codes given below. See, try to match the acids and their sources given in the column 1 and column 2. We know acetic acid is present in vinegar. Citric acid is present in citrus fruits like oranges and lemons. Tartaric acid is present in tamarind and grapes. Oxalic acid is present in tomatoes. Now what will be the correct matching? See the matching here? It is. Now select the correct option. A is matched with 4. A is matched with 4 only in D. Okay, this will be the correct answer. Now let us check the remaining also. B3, yes. C2, of course. D1, yeah, it is correct matching. Okay, acetic acid is in vinegars, citric acid is found in oranges, tartaric acid is found in tamarind, oxalic acid is found in tomato. Okay, next. The H plus ion concentration of a solution is 1.0 into 10 to the power of minus 5 molar. The solution is the concentration of H plus ions is given and asking to find out its nature, whether it is acidic or basic. If we know H plus ion concentration, we can find out its pH value. So if we know pH value, we can say whether it is an acid or base. See, the pH value given, H plus ion concentration is given 1 into 10 to the power of 5 moles. So if you take it as H plus ion concentration, we can find pH value as by using the formula pH is equal to minus log of the formula for pH minus log of H plus ion concentration. So if you substitute the H plus ion concentration value in this, it becomes minus log of 1 into 10 to the power of minus 5. Now if you simplify this, it can be written, it is in the form of log of A and B. A into B. It can be written as log A plus log B. It becomes now minus log 1 and minus 10 to the power of minus log 10 to the power of 5. Okay, minus log 1. Log 1 value becomes 0. So 0 plus, okay, minus is, no, let us write instead of this, let us write minus. Okay, minus log of 10 to the power of minus 5. So this numerator, it is in the form of log A power B. This B comes in front the quotient place. So minus 5 comes in front. It becomes minus into minus 5 log 10. We know log 10 value is 1. So total value becomes now 5. So we are finding here the pH value as 5. If it is having the pH value 5, what kind of substance is this? We know the pH value, if it is in between 0 to 7, then the solution is said to be acidic. Okay, the substance is the concentration, the solution is acidic in nature if the concentration of H plus ions is 1 into 10 to the power of minus 5 molar. Okay, if the concentration of H plus is given, we can find out its pH value. If we know the pH value, we can identify what kind of substance is that. If the pH value, if we find in between 0 to 7, then the solution is said to be acidic. If the pH value is found in between 7 to 14, then the solution is said to be basic. If it is exactly 7, then we can say it is neutral. Now we got here pH value as 5, so the solution is acidic. Next, the pH of three solutions A, B and C are 6, 4 and 8 respectively. Which of the following is correct option? And they are giving here decreasing order of acidic strength. Say which is more acidic among these. We know the value, the pH value as it is decreasing, its acidic nature increases, because we told the substances with pH value 0 to 7 are acids. As the pH value decreasing from 7 to 0, acidic strength increases. So the one with less pH value is more stronger. Out of these all, which is having less pH value? B, because for this pH value is given 4, whereas for A it is 6 and for C is given 8. So now the one with the lowest pH value is B. Next A and least for C. So this is a decreasing order of acidic strength for these compounds or solutions A, B, C. So in this order they are. B is greater than A is greater than C. Where is it? Yes, in third option. Okay, this is correct one. Okay, next one. Dilute hydrochloric acid is added to solid sodium carbonate. It is observed that. Yes, what are the two mixes, two solutions mixed? Hydrochloric acid and sodium carbonate. We know when hydrochloric acid reacts with sodium carbonate, they form sodium chloride salt, water, and along with these two, carbon dioxide gas also is evolved. Now, as this carbon dioxide gas is being evolved, some effervescence will come, brisk effervescence will be produced out, it occurs. So, because of the evolution of carbon dioxide gas, brisk effervescence is occurred. Okay, next. Plaster of Paris is made from. Yes, in the earlier questions we have seen, when gypsum is heated, it gives plaster of Paris. So plaster of Paris obtained from gypsum. Next, a drop of liquid sample was put on the pH paper. Then the paper turned blue. Then the liquid sample must be off. So see the color change given here. The pH paper turned blue. When the pH paper turns blue, when it touches or it reacts with basic substances, the color of pH paper will be blue with basic solutions, and it will be red with acidic solutions, and it will be green with neutral solutions. Now they told here pH paper turned blue means the liquid sample is basic in nature. See the components or the solutions given in the options. Out of this, which is basic? We know lemon juice is acidic in nature. Hydrochloric is also acid. Ethanoic acid, in the name itself it is also an acid. Now sodium bicarbonate is one of the basic substances. Its solution gives blue color to the pH paper. So it is correct answer. Okay. Yes, he see here alkali substances give blue color with pH solution. As basic nature increases, dark blue color is given to the pH paper. So bases generally give basic. Sodium bicarbonate is one of the bases. Next, read the given statements and mark the correct correct option. First statement you see pH of hydrochloric acid solution is less than that of acetic acid solution of the same concentration, isn't it? Yes, we know hydrochloric acid solution is the pH of hydrochloric acid solution is less than that of the acetic acid solution. Yes, it is correct because strong acids will be having less pH value. We told this in the pH scale, as the pH value decreasing from 7 to 0, pH acidic strength increases. We know hydrochloric acid is one of the strong acids, whereas acetic acid is one of the weak acids. So strong acids will be having lower pH values than the weak acids. So the pH value of hydrochloric acid is less than that of acetic acid. So this statement is true. See the second statement. In equimolar solutions, means the same concentration, the number of titratable protons present in hydrochloric acid is less than that present in the acetic acid. Titratable means free H plus ions. So the strong acids can produce more number of H plus ions. That means more number of titratable protons. But here they have given hydrochloric acid is having less protons or less H plus ions than acetic acid. Is it true? No. Hydrochloric acid is stronger acid. Means it can produce more number of H plus ions than acetic acid. We know acetic acid is one of the weak acids. It produces less concentration of H plus ions or protons. So it is given in the reverse way. So it is wrong statement. Now which will be correct answer? Statement 1 is correct. Statement 2 is false. It is correct. Okay. Next one. The difference of water molecules in gypsum and plaster of Paris. And the same it is asked again. We know the formula of gypsum is CaSO4 2H2O. Means two water molecules are there in this formula. And the molecular formula of plaster of Paris is CaSO4 half H2O. It is called hemihydrated calcium sulfate. Means the number of water molecules in plaster of Paris water molecule is half, and gypsum is called dihydrated calcium sulfate. Okay, now the number of molecules are 2.5. Now the difference between these two, what is the difference? 2 minus 1 by 2. We calculate, we get it as 3 by 2. Okay, next. An aqueous solution with pH 0. What is the nature of the solution with pH value 0 we told? Yes, the solutions with pH value 0 are said to be acidic substances. The pH range from 0 to 7 are acids. The pH range from 7 to 14 are bases. The solutions with pH value exactly 7 are neutral substances. Now, the solution with pH value 0 are acidic substance or acidic solutions. Okay, not neutral, it is acidic. Neutral means the pH value should be 7. The pH value is given 0, they are acidic solutions. Next, the order of acidic acid resembles that of. Okay, this we have in the previous questions also. Order of acidic acid. We know acidic acid is present in vinegar. So the order of vinegar and acetic acid will be almost same. Vinegar. Vinegar is a correct answer. Next, when aluminium is added to potassium hydroxide, which gas is evolved? We know aluminium on reaction with potassium hydroxide, they form metal salts. Potassium aluminate it is called. Potassium aluminate is formed. Along with that, hydrogen gas is evolved. When metals react with the strong bases, they form metal salts, and they release hydrogen gas. Hydrogen gas is evolved. Okay, hydrogen gas. Some metals like aluminum, zinc, they react with strong bases like sodium hydroxide and potassium hydroxide, and hence they form their respective salts. If here aluminum react with potassium hydroxide, it forms potassium aluminate salt and releases hydrogen gas out. Next one, acetic acid was added to a solid X kept in a test tube. A colorless and odorless gas was evolved. The gas was passed through lime water, which turned milky. It is concluded that. What can we conclude here? So to find out what is X here, first let us see the nature of the gas. It turned lime water milky. We know the gas which turns lime water milky. What is it? Carbon dioxide. So carbon dioxide is a gas produced in this reaction. Now, if you see, observe the options once. Which substances generally they produce this carbon dioxide gas on reaction with acids? We know metal carbonates and metal bicarbonates generally they produce carbon dioxide gas on reaction with acids. So here they told component X or the solid X reacts with acetic acid and producing carbon dioxide. So the solid X must be a carbonate or bicarbonate. See in the given options which is given, carbonate or bicarbonate. You observe here the second one. Solid X is sodium bicarbonate and the gas evolved is carbon dioxide. This we found already. So the component is sodium bicarbonate. The sodium bicarbonate on reaction with acetic acid produces salt, water and carbon dioxide gas. Okay, it is correct answer. The salt formed will be sodium acetate and water are formed. Along with these two, carbon dioxide gas is evolved. Okay, it is sodium bicarbonate. Okay, thank you for watching our video. Please subscribe our YouTube channel. It is Aims Today and our website aimstoday.in for latest updates and recorded videos. Thank you.